Alright, given the sequence is 6, 11, 21, 41, and 81, find the difference equation that represents this. First point, we're not told that it's arithmetic or geometric, but it is a first order difference equation. We should be told that. So this is the formula that we're going to use. Now, t of n plus 1 and t of n are the variables in each case, representing the term 6, 11, 23 for t1, t2, t3, and so on and so forth. R and d are constants. So if I have two constants, I'm going to need two equations, and I'm going to have to solve those using simultaneous equations. So take the first two terms first. So that would mean that t2 is 11, t1 is 6. Here we go. t1, t2, and then if we put 1 instead of n, we get t2 is equal to r times t1 plus d. Fill in 11 and 6 for t1 and t2, and that gives me my first equation. Now, if I take the second and third terms, then the relationship between the third term and the second term is given by t3, which is 21, is r times 11 plus d. There are my two equations. Solve the two of those. I get r is equal to 2, and I get d is equal to minus 1. So once I have the r and the d, I can then fill it into the equation up here. So I get t of n plus 1 is equal to 2 for r, t of n minus 1, which is that thing there. And you can do that for all of the sequences that you're given if you're asked to find a difference equation. This will work for all first order difference equations, but bear in mind that if it's arithmetic, you don't need an r anymore, so you just need one pair of terms to solve for the d. And if it's geometric, you don't need the d, so it's simple also, in which case you just need to get the common ratio between the two.